Right.
So, hello, Miller. Thank you for coming to the interview today. And I'm Miss Fu. I'll be conducting your interview today. So
Mhm.
for the technical interview, there are going to be two questions where you can choose from. One is from the topic list, and the other one is from Stack. You can choose like which one you're going to work on.
I think I'll go for the lists topic.
Okay. So I'll first um describe the situation to you and I'll provide an example, input and output, and then you can work on your solution. So this question is from LeetCode. I encountered before. It is called plus one. So basically you're given um a large integer represented as an integer array. Um, for example, you may get an array 1, 2, 3, and where each digits I is the ith digit of the integer. You have to add one to the least significant index. So, um, for example, I can write it on the doc. For example, if you're given an array 1, 2, 3, what you have to do is you have to add one to the integer it represented, which is 123. You have to add one to it so that it becomes 124. And what you have to do next is you have to return the array 1 to 4.
Hmm.
And we can work on it based on the assumption that the large integer does not contain the leading zero. So the first integer will never be zero.
Hmm. Okay. So I'm returning both an integer and an array, correct?
I think you only need to return the array. So you can,
Only the array.
yeah. This is what I have the the name of the function. And you can work on the solution in this function.
All right. Well, the general idea, again, is to take the lowest indexed number, correct? So in this case, index 0, and then add it to the last index, or the value that is in the last index of the array, correct? Or the vector.
Um, you're only going to add one to it.
Okay, sorry. So
So
I'll take,
if the array is like 2, 2, 3, what you have to do is add one to 2 to 3 and then return 2 to 4.
okay, got it. So I'm adding one to simply just the last value of, or the last indexed value in the vector.
Yes.
Okay. Hmm. Hmm. That there are a lot of ways of approaching that. Um, if I'm just returning the array, sorry, just return the vector rather. Um, hmm. Just return the vector. I'm trying to think of the exact syntax as to how to approach this, because I get the general idea, which is to address the final value of um, of the array, or the final value of the vector. So,
Mhm.
hmm. I mean, I'm gonna do an I equals 0 approach. What I want to try and do is just take the final value at 1. Final value and add 1. And I still need to return the vector. Hmm. Now that's the tricky part. How do you return a vector?
So the digits is a vector in the first place.
So I just do return digits in that case.
You can
Just for the
you can just return make some changes to digits and return the digits, or you can just create a new vector.
hmm.
It depends on you.
All right. Well, hmm. I mean, oh, one more thing. What happens if I do an integer overflow? Say, for example, the final value in this array was 9, and I had to add 1. Would that loop around to 0, or would that loop around to 1?
If you're doing if the last integer is if the last digit is 9, and when you do the calculation, for example, 229 plus 1, it becomes to 230, and you also need to modify the values in the vector digits.
Hmm. Okay. That seems like a tricky one. And then what if all the values in the array were 9s? Would that just simply be a case where I break the function?
Um, I think you still need to do it. It just like keep recursive to the first index of the digit. So, for example, if it is 99 and then you plus 1, then the vector of arrays will become, so there will be like 3 digits inside, which is 100.
Yes, but what if it was 999? Because then that would equal 1,000, but we don't have we don't have 4 digits to represent that.
So I think it is better to create a new array, right?
Okay. Um, regardless, the approach for the final, or sorry, the approach for just the general idea of adding one to the given index. Because I know that you can't do vector size of, because that's just the size of the vector.
Yes, for vector, you can use vector dot size.
And then couldn't I use, say, digits size minus one to get the final value?
Yeah, I think you can do this.
Well, in that case, we will push that back. Well, I'm not going to push that back just yet. And then I'd have to pop the last. Yeah, because the idea would be to pop the final value. So I'm not sure if that would create errors. I'm not even sure if this is the correct syntax per se, but at least on a high level, the idea applies. Wherein I'm creating an integer,
Okay.
represents the final value in the vector. Feel free to check me on this. Say if this isn't valid syntax.
So you want to check the digits dot push line? Or
Okay. Let's see. Well, I'm curious as to what I'm doing wrong here. Could you point me in the right direction? Could it be maybe dot new file?
what is, oh, okay, I see the new.
Because I thought maybe putting it in the parentheses would correct that.
Oh, I think you can just put the new final inside the parentheses, just the same as what you
Okay.
did. Yeah.
Yeah, I figured that would probably be the
It works
case.
fine. Yeah.
Uh, Um, so that takes care of the initial proposition, which is just to find the last value. Uh, so create that new value, get rid of the last value, and then push that in. Because I presume it would just take that last place when it goes into push, given it's a stack. Um, but from there, that only takes care of one problem because that doesn't deal with the possibility of say this number being 9.
Yes, there's the edge case where it should be 9.
Yeah, that's the next portion. Um, well, what if, should I put my if statement between this, or should I make it separate? You know what?
I see you're trying to identify the case where when it plus 1, it exceeds 9.
Yeah. And then I'm also trying to account for, say, a recursive situation where you have multiple 9s back to back. So that's why I didn't want to, in this case, I was really just going to write, digits size minus 1, equals whatever, 0 or what have you. Um, I don't know if this is the right approach because, well, a for loop would iterate through any prior values. Hmm. Because I get the idea of just having a base case, right? I understand having a case for such a situation, but how would I get this to operate recursively unless I were to make everything in the for loop? Hmm. Well, no, it doesn't make sense because I has to iterate I equals digit size minus 1. Because I wanted to iterate backwards.
Would it be so if you're going to iterate it backwards, is it going to be is bigger than 0 or I it
Greater than or equal to 0, because we're counting down to the 0th value. The first value, the first index rather, in the array, or in the vector. So that way it cascades backwards.
okay, yeah, that makes more sense.
And then I also want to stuff another if conditional statement in there, but I don't know if that'll work per se. Because we want to check now if, well, no, that doesn't work either because I is already being used to iterate. We need another value for this. That necessitates a recursive function, which doesn't work. Yeah, no, that's a tricky one.
And it's difficult to handle the edge case for this one.
Very difficult. Oh, if it's greater than.
What if try like if the digits is bigger than 9, you just minus the value by 10 so that for its previous integer you can add 1 so it makes it like correct.
Yeah, that's what I was thinking of doing. The indentation on this is really, really wonky. Okay, so if this digit checker is greater than 9, we will set digits at I to no. Well, in this case, yeah, we'd set it to digits of I plus 1. But say it's a value like 20, and that wouldn't be necessarily valid. Or say, 23 instead of 9. then we'd have to bump that up by at least 2. Hmm. That is a very interesting problem.
I think you have got most of the ideas of how to approach this problem. So it's just you have to first add 1 to the last digit and then traverse through the digits from the right to left and to see whether there is a digit greater than 9.
Correct.
And I think you did it. What you did well is that you're going to see like if the digit is bigger than 9, how can I modify the previous digit? So I think what you can do is that, for example, if one digit is like after adding 1, it becomes 10. What you can do is you can minus 0 to let it become 0. And for its previous integer, no matter what is it, for example, if the original one was 29 and that integer is 2, you can just add 1 to make it become 3. So then the two numbers becomes 30.
Yeah. I guess my concern is for any values greater than 10, like say if I'm adding, multiple tens of, if I'm adding 30, so on and so forth, because in that case, simply adding 1 wouldn't be valid. In which case I'd probably have to add an additional checker to see if it's, say, a multiple of 10, and then maybe add a modulus of some sort. So say if I'm adding 23, well, I'll mod that by 10. Well, no, not mod that by 10. Modulus wouldn't be valid in that case, no, because that'd just leave 3. Yeah. Need to divide it, floor divide it by 10. In which case that would provide a valid value.
I think you have like your approach is just like the easiest way. So you traverse from like backwards and then to see if it is greater than 9.
Well, that part's already implemented for the most part, because we have our initial for loop, and if I can get this to properly indent, yeah, because we have a for loop here.
Yeah. Um,
That
so
iterates backwards.
if the digit checker is bigger than 9, which is after what does the digit checker in your code mean?
Well, I guess oh. Oh. I forgot to signify that, because it shouldn't be the iterator itself. It should be the vector at this iterator. So digit checker is meant to represent just the value at this specific point, or the value at the value of this particular vector at this particular index. So in this case, say we're at index 2, assuming 0 is the beginning. So we're at index 2 here, or 4. that would be the digit checker. So it basically just logs the current position. And then it checks if this is greater than 9. Okay, so we have that if digit checker is greater than 9. Then it's going to add 1 to the current digit. But it's not supposed to do that because it should be,
I think so. If the digit checker is bigger than 9, yeah, you're correct now. I think it should be you have to modify the previous digit.
yes. But that should be if and only if is less than 19, sorry, greater than 9, but less than 20. And then for all the cases, maybe I should have a modulus. Or not modulus, division. I believe that's a valid function. Correct me if I'm wrong, to make sure.
Yeah, um I think you got most of the ideas. So I like the way how you like going backwards to see if the digit is greater than 9 and modify the previous digit. But I think it is a little bit like complicated here. So you're like thinking multiple situations where the digit checker is bigger than 20. But I think that you can only consider if the digit checker is greater than 9.
Well, I guess I could probably, I mean, theoretically, I could probably just do the same thing here, because if you think about it, say, any value from 10 to 19 should still floor to 1 if I were to divide it by 10. So I guess I don't really need this second function. Thank you for pointing that out. That helps a lot, actually.
Okay. And I think your function effectively works, I think. And so it can like you have almost include all the situations, the edge cases. So for me, if I'm going to, so it's like from another point of view. If I'm going to approach this problem, I may be using creating a new array, and so that I can just insert the digits inside. That's what I would approach this problem. But I think your solution to work just on the the original vector digits, it would be better for me.
Well, since we're working with vectors, I figure I may as well take advantage of that because that is one of the advantages of using that data structure over an array. Where for an array, you'd have to probably create a class, a modifiable class of arrays, or you'd just have to create a whole new one altogether. The implementation would be a little different in that context.
Yeah. Do you still have like any questions for this problem?
Um, I'm still curious as to how I could handle this in the event that in the event of say all the numbers in the arrays being nines. But otherwise, I think that should solve the problem.
I think what you thought was that you're going to do a division by 10 so that you can get like what is left after division. But what I would do is because divisions cause a lot of problems. So what I would do is that I would minus everything by 10 because it would not be greater than 20. So if I just minus it by 10, it would still it would be like one digit.
Hmm. The thing is, if I minus everything by 10, that would turn, well, if I were to minus every value by 10, that would turn this into -8, or these two into -8, um, which wouldn't help. Now, if it was just taking all the values from the array, putting them into a single integer, like smushing them all together, and then reloading them into an array, then I could see that.
Um, so you're talking about if it is the case that it's 223 and then you plus 1 to 224. And when it minus 10, it will be negative. Or
Well, I guess where I'm confused is this middle part. Am I supposed to implement code that, say, converts this array into an integer? Am I supposed to print it out, or am I simply just adding one to this final, to this last value in the array and then returning it?
I so for the problem, it should be only work on the arrays. Yeah, it just I'm like giving the insight of how this actually works.
Yeah. Well, I can understand like the -10 as an abstraction. Um, in this case to address integer overflow. Uh, that reminds me.